Oh, that sounds fun.
Yeah, just made up math.
Sounds like a creative.
Actually, the professor for that class was awesome. His name was Samson Adeliki. He was a black guy, but he was British. He had a British accent. And he'd come to class, he'd bring his own chalk. This is chalkboard days. So he'd bring his own colored chalk and stuff like that. And we were doing the homework. He'd draw a picture. Like, this is Sally. Sally was a very, very diligent student, very diligent. She would do her homework, and if she messed up a problem, she'd rub it off, do it again. Guy was a nut job.
The code is not on.
What's up?
The code is not on.
The code is not on.
Recorder.
Yeah, it is. It's just that one screen. It's something about Keynote takes over the screen or something like that.
Okay.
Yeah, that tricked me the first 7 or 8 times I was using this recorder several semesters ago.
At least you're
Yeah, but anyways, so I had a zillion math classes, but what ends up happening? So this is actually an important lesson for everybody in here. Shut up! I'm about to give you an important lesson to be studious. So, as undergraduate students, you just go through the motions, right? Take these classes, it's the game, blah, blah, blah. So I was a computer science major. I was always interested in programming, but I was at an engineering school, so we had to take, basically you had to be a math minor because computer science required so much math that you just took one more class and you got your math minor. Okay, so I took a zillion different math classes. And what did you do? Or what did I do? I learned all the tricks to go in and do the right, get good grades. And I did well in my math class. I had straight A's and that kind of stuff. But I remember like next to none of it. When I was in grad school, I took an artificial intelligence class where I had to go back and relearn integration because I started seeing how some of how calculus tools are, calculus skills are used in higher science. But when I was taking it, just like, oh, which integration trick is this one? And you just do the problem, and then good enough for the test, and then you learn it again for the final, hoping that hoping that you've done it well enough that you can at least get through the final pretty decently. But so the lesson I learned is I had to go back and relearn this stuff when I was in grad school because I didn't really learn it the first time. I learned the tricks to do it the first time. But that was years ago, so now I've forgotten it all over again. But there's bits and it's there. So once I start doing it a bunch, it resurfaces. So the knowledge is in there somewhere. I'm just old. Well, not that old, but older. A lot older than you guys, most of you at least. I think I'm a lot older than everybody in here. Sometimes I get a grad student that's older than me. Yeah, but in any case, I can't with any sort of real confidence tell you whether this is right or wrong. So I'm going to take her word for it. So your premise is that our algorithm here can't work because we have to somehow take sine into account, correct? Okay, can you help me walk through this and we'll see if something kicks in my brain?
Because you can't just take proportions, you have to take, it has to have trig in it. So it would have to be the sine of 73 over 120 and then the sine of 17 over y. You can't just do 17 over y and 17.
Okay, so you think it needs to be sine of this over 120. So you're still doing the proportion.
Yeah, you can still do it the proportion way.
Okay, but you tried to do that and couldn't come up with the...
Well, I just didn't.
Oh, I got you. It's not that you didn't come up with the answer. You just decided to go lazy and just do what we did in class to get the assignment done.
Or I just didn't do the assignment because I'm not doing this class.
Oh, that makes a lot of sense, actually. I forgot about that. I'm still calling it lazy. But I do appreciate that. Okay, so did the math work out when you did the sine of those?
Well, you get that y is 36.6 something, so then it would just be that divided by 120. So you should have a proportion of 0.3057.
Okay, so as of right now...
So if you just put the sign around the angle.
Okay, so we need to say, okay, so this 90 minus launch angle, that's fine. That gets us our 73. So now for our... you're saying we can't do...
You just have to put sine around the angle. So sine of the quantity 90 minus launch angle and quantity.
Oh, so sine of all this? All of this?
Yeah.
So it'd be basically sine of 73.
Yeah.
Okay, but then where does the
But you have to have, like, you can't just do the, like, .0 or .608, because that's just the,
Right, but so sine of this is going to give us a new value over on this side.
Yeah.
Are we still dividing it by ball speed?
Yeah.
Okay, because this is ball speed.
Yeah.
Okay, so that's correct. But we never have to, when you were explaining before, I thought it was sine of something over sine of something else.
no, sine of something over something is equal to sine of something over something.
Oh, okay, I gotcha. So then it's whatever this comes out to, and this is the sine of 17
Yeah.
over y, correct? Okay, I gotcha. So we're still taking the proportions, you just have to do it with the trigonometry on both sides in
Yeah.
order for it to be accurate. So we kind of lucked out that it was close enough to fake us out.
Yeah.
Okay, so let's go back, so we're going to say current launch angle, which is, this should actually be the sine of the current launch angle, right? So sine of current launch angle divided by the sine, let's do another parenthesis here, the sine of 90 minus current launch angle divided by ball speed. Okay, got it. So you're happy with that formula. Let's go in and let's plug that in and make sure that everything looks legit. Did we do it at the
Golf ball, I think.
It's in what?
Oh yeah, it is a golf ball.
Okay, so this is going to be current launch angle, so we need the sine of that. Divided by the sine of that crap. We actually don't need the second parameter here. So sine of all this divided by ball speed. I think that's
Rid of the one of the ends there.
no, the one at the end matches up to this one before the sine.
Okay.
We originally had another parameter parentheses around these, but the sign houses it.
Alright.
Okay, so let's go ahead and save that, and let's make sure that it still looks legit. Okay, so we're still looking pretty good. All right. Oh, so I don't forget extra credit opportunity. It's going to be a good extra credit opportunity, actually. I tend to, over the semester, give lots of little pop quizzes. A lot of times I give pop quizzes on things that are supposed to be difficult, so sometimes there's bad grades associated with pop quizzes. I have an extra credit opportunity that you could either get a free A on 1 or 2 pop quizzes, depending on your level of participation. The date is Sunday, March 9th. I'll put this in, it's called Concordia Sunday. Sunday, March 9th. There is a presentation called Theologians in the Hot Seat. So there's going to be 4 or 5 theology professors and or pastors, some of which are from Concordia here, actually all of which will be from Concordia here, answering theology questions for the audience. This is going to be at Beautiful Savior Lutheran Church in Mequon. So, the scoop is this. 1 free A on quiz if you show up to the church service from 9 a.m. to 10 a.m. 1 free A on quiz if you stay for the presentation and free brunch. So you get free food out of it, like cooked food, not like pastries and stuff. Huh? Which part? The free food?
Yes.
All right. So, 1 free A on the quiz if you stay for the presentation and free brunch. So that's following church service. So I would encourage everybody to get 2 free quizzes. Show up for church. Sit through it. If you've never been to a Lutheran service before, it's interesting. It's like Catholic Light. The pastor of this is my church. The reason I'm advertising is my wife is on the committee that puts this on. So we want to promote it. They spend a lot of time making sure they get plenty of food and stuff like that. So it looks bad on the committee if we don't have a good Concordia turnout. You know, the whole purpose of this day is for Concordia students to come to the church, experience the church, eat free lunch, and hopefully that's the gateway drug for you to come back again. But, you know, I'm not giving you extra credit if you come back again, but I'll do my part for Christian worldview to get you sitting in front of the church and listening to a service and then getting a free meal out of it and listening to people ask the professors questions. It actually should be pretty good, and it's pretty good food. There's some fairly good cooks on the committee. Won't cost you a dime. And this is, the church is about 7 minutes from campus. It's on Mequon Road. So if you just take Port south to the intersection for Mequon Road, turn right on Mequon Road, turn right at that bank, and you go down that road for like a mile or something like that. You'll see a little white sign on the right that says Beautiful Savior Lutheran Church. Just turn right there. The church is first driveway on the left. So not far from here. You have to make a left, then 2 rights to get to the church. So all of you are invited. I'll have like a sign-up sheet there for you to sign into the service, as well as sign in for the presentation afterwards for free lunch. You won't be penalized if you don't come, but you know I'm offering some free passes on quizzes if you'd like to come. So no penalty, whatever. All right, everybody have the information down? Okay, perfect. You may get double points because some of your other teachers who are also members of this church, tends to be a lot of Concordia people who go to my particular church. They might also offer you extra credit. That's been something that's happened in the past, so you might be able to double dip on this. But, you know, if you want, you might just drop the date to them and say, hey, did you know about Concordia Sunday? You know, my other professor's giving me extra credit. Can we get extra credit for it? Something like that. That'll be your motivation is to get more extra credit. My motivation is to get more people there. All right, sound good? All right, so now that I've done that plug, oh, and that's a Christian worldview point there too, right?
Yeah.
Actually 2, because it comes with free lunch. All right, so in any case, I guess we're looking more mathematically legit now. Okay, perfect. All right. Now, just for the sake of argument, this is on the golf ball, right?
Yep.
What did you say the number should have come out to for 17 degrees? Yeah.
It should be like 0.3057.
Okay. Oh, actually, what should y be?
Y should be.
I just want to have it print out to make sure that we don't have that weird bug where we updated the formula, but the formula is not really updated.
Y should be 36.69.
Okay, so let's just go ahead. I'm going to put out a. I'm going to tell this guy to display his text for Y. You might have to make our golf ball a little bigger so we can see it. I just want to confirm that our math is correct. I think the math is correct. I just want to make sure that Game Salad is, since we just went and updated it, I remember having an issue with that before. I feel confident that her math is better than my math, so I'm good with that. Motion, linear velocity, Y. And we probably want it in black. And we'll We'll squeeze the font down, but let's go ahead and let's make this guy 50 by 50.
Gigantic golf ball.
Okay. So, prepared for launch. Let's see what value we get. Oh, we're not seeing the whole thing. Hold on. Width, 100.
Even my uncle could hit that.
Oh, almost. Little more, 150.
Yeah.
There we go. 36.68. Okay, perfect. So let's get our golf ball back down to 15 by 15. And we'll dump this display text. Okay, now we can currently adjust our ball speed. Now we need to also be able to adjust our launch angle. So let's go ahead and throw that in there. So we're going to take a very similar approach to what we did before, and this is what you were doing for your assignment. So we're going to have launch angle up. And we'll have launch angle down. And let's just see what the size of these were. Do we make them 25 by 25? (25 by 25). Then launch angle down. Okay, so while I'm filling this in, let's think about what's coming next. So what's coming next is, so we can at least start, boom. So we can at least start thinking about it while I'm just going through the motions here. When we hit start, we want this golf ball to start going, which it's already doing, right? And all we're doing is here is letting it adjust that 17-degree thing. So I'm just kind of going through the motions of this. But we need gravity to start taking effect on this golf ball, correct? Now, we want the golf ball to ultimately, I mean, it should look like an arc, right? It should go up and then start coming back down. Because ultimately what we want to know is how far, distance-wise, did it travel? Okay, so we need it to hit something. All right, so for right now, I'll just kind of, as we have time, start filling in the blanks for this stuff, because we can just hard code our launch angle for right now. So anyways, we need this guy to start falling out of the sky. Now, a problem we have right now, we'll just use our launch angle up guy right here. Notice gravity is having an effect on him, and it's a cumulative effect, right? The longer gravity impacts him, the faster he falls. Okay, so this is like jumping out of an, again, you're in a vacuum, jumping out of an airplane with no wind resistance, right? You will start off at a certain speed and then speed up until you hit terminal velocity. So gravity has a cumulative effect until a point where you hit a maximum speed, which is what, 9.8 meters per second? Yep. Okay, so we really need this golf ball falling at the same rate, but remember that it is launching at a certain rate. So we're launching this thing at a ball speed of 120. Will it be 120 miles per hour all the way through? It's going to be slowing down constantly as well. How do we mimic the amount that it's slowing down? Go ahead.
Drag.
Okay.
Because that would simulate like wind resistance.
Okay. Initially, I want to do this as if it's in a, well, let me think about that. If it's in a vacuum, will it slow down? I think so.
Yeah.
Gravity would still slow it down.
But in this game, gravity is only pushing downward because we only set the gravity to y. So then the wind slows down.
Okay. So can we push gravity the other way too? Is that correct? Is it correct to have gravity going straight down as well as gravity going into it?
Physically, no. Gravity is only a downward force.
Okay. So how do we simulate this?
We we can take wind as a factor for that.
I want to ignore wind right now. We're going to try to fake wind later. Sorry, somebody wanted to try to call me in a minute. I just told them I'm in class. So I want the ball to launch, continually slow down, because gravity is having an effect on it. Okay, as it's falling out of the sky, gravity is going to have an effect on it. Would gravity in and of itself slow it down? So if we're in a vacuum, would it actually slow down? Or would it constantly be traveling at 120 miles an hour, but eventually it's going to hit the ground? Okay, so in a vacuum, it's going to stay at 120. So we're not going to change its speed on the x, but we do need to change its elevation on the y, correct? Now, as it stands right now, its elevation is a fixed amount. We set the y to whatever, and then it begins falling, correct? How are we going to, we set it to y, and now it's just a constant, because it's just this math that she fixed for us. So now y is, once we set it, that's it, and it's not going down. We need to adjust that y based on gravity. How are we going to do that?
We can use a condition where gravity, the highest point, and is equals to the gravity. So after that, it starts declining when we compare the highest point and it's equals to gravity.
Mm-hmm.
Then it starts declining. We can use a for loop for that. A condition that if it is equals to the highest point, then it starts into the negative side, like minus.
Okay, so we'd have some sort of top level variable that would be current downward force. Okay, and that current downward force is going to start off at 0, and then every second it will drop by the force of gravity. Correct? How do we make that variable? So I don't disagree. Let's start off with that. So at the game level, we will create a attribute, type integer. Actually, we need this to be type real. Downward force. And it'll start off at 0. I say real because we need to be able to represent decimal places, but I think integers seem to be able to represent decimal places too. So, but we'll just use a real because it seems to make more sense. We need this to increase, correct? So that we can subtract it from the y. How do we make this decrease? By the force of gravity. Go ahead.
Timer that increases. I was going to say a timer that increases gravity, but that wouldn't work. A timer that decreases the y constant in the constraint attribute equation.
Okay. Okay. Where would the timer be? Let's start with that. In the golf ball?
Yeah.
Okay. So let's go back and look at our golf ball. Now, we're constraining the y velocity on this guy, this giant formula thing. And ultimately, what do we need to do? We need to have a minus on the end of that. Minus some force, correct? So we can actually go ahead and throw that in, can't we? So all that crap minus our game's downward force. So initially, this should have no difference, right? Because we're not actually updating our game's downward force. All right. So now let's go ahead and let's put a timer somewhere. Just for the sake of testing, let's put it inside of the start button. So I'm going to go ahead and we're going to set a timer. And this is going to be inside of that rule. Okay, so whenever we click on the start button, when all this other crap happens, we're also going to start a timer. As I'm doing this, I want you to think about why a timer might not be a good use here. Why it might be not give us an accurate result. But we're going to do it first just to make sure we at least get an effect similar to what we're looking at. And this comes down to what we were talking about before, where something visually might look okay, but is it actually okay? So we're going to say every 1 second, what are we going to do? We are going to change an attribute What attribute? We're going to change our games downward force to whatever it currently is plus what's a good amount per second.
Do we go plus or do we go minus?
We're going to do plus because we want it to get bigger because we're subtracting it from the ultimate. Actually, hold on. Let me think about that. Yeah, we want it to be plus here. We want it to get bigger on this side because we're subtracting it from the y on the other side. Why don't we just say 25? We're not looking for any accuracy at this point. We're just looking to see if we can make that golf ball look like it's coming out of the sky. Then we'll figure out how to make it work correctly. All right, so we'll go ahead and hit start. Again, just for the sake of argument, let me get this guy out of here. That was my hint, by the way, the guy I just deleted. Hint, hint. Let's start thinking about that. So golf ball. So again, we'll make our golf ball's width 150 by 50. Is that what we had?
Yeah, close enough.
Okay, and we're going to make this guy display the text. And he's going to display his own linear velocity on y. And we should see, if this is all working, we should see that decreasing. Correct? Oh, let's turn it into black text. Well, I think I also had the font smaller, right? 18.
Yeah.
Otherwise, I think it's going to... Okay, it's not decreasing.
Was that the bug where it doesn't?
Well, that's what I'm wondering. I just want to make sure the stuff is happening correctly.
Yeah.
Okay, so we need to go back to our golf ball. So I want to make sure it's updating. So I just subtracted 1,500 from the y. So this guy should go down at a pretty sharp right off the bat. Just it should not climb into the.
No, just
Oh, okay. Well, definitely updated. so we've done that check. So now instead of minus 1,500, we want to subtract our games downward force. Yeah, see, it's not updating. I'm gonna have to put that whole freaking formula back in.
yeah, maybe.
Not the end of the world, right?
Here, what is our downward force at right now?
Plus 25%.
Yeah, let's somewhere just display that. Let's see if that's updating at least. So we should see that update become a bigger number over and over again.
It's not.
Okay, and that's not.
I think we need to do some comparison over here with the downward with the golf speed. Like golf speed is equals to something related to the down speed.
Okay.
120 minus the down speed, and down speed is equals to down speed minus plus 25.
Well, aren't we doing that? So in this timer, we are changing an attribute, our game's downward force, to whatever it currently is, plus 25. But this is not,
Not updated.
yeah, it's not occurring.
I think the golf speed should be like negative golf speed minus game downward has to be there, so that when the downward is 25, so the ball speed also decrease by 25.
Well, no, we can think about that. That'll be more of an accuracy thing. But for right now, this timer's not running because it should be updating our game's downward force by 25. So let's figure out what's going on there. Let's start by doing this. I'm just going to throw the timer out here in the middle of nowhere. And we're going to say every 1 second. What are we going to do? We're going to change an attribute. We're going to change our game's downward force to be whatever it currently is plus 25. We just want to prove that we're updating that. Oh, thank you.
Does downward force have any effect right now?
Downward force isn't updating.
Is it? Oh.
Yeah, right now we're actually printing out just that variable.
Okay.
Forget about it minusing from our thing. Downward force is staying at 0.
It's working.
Huh?
It worked if you did it like
Okay.
that.
All right. So that seems to be working. The question is why is that not firing if we bring it inside of this rule?
Are those constraints?
Do we need a separate?
Put it above
Do we
it.
need a new scene to see if it actually is a separate touch rule?
Well, it seems like maybe. So you want to have another rule in here. I'm sorry. Let's back that out. So we'll create a rule that says this actor receives touch pressed. And you want to throw this timer inside that one. We kind of respond to it twice. I think this might be one of those matrix issues. Yeah, I'm trying to think. There might be a thing that says the timers don't work inside of rules. But that shouldn't be the way it works. So this timer works outside of it.
Mm-hmm. Not inside.
Do other persistent behaviors?
Say this again.
What's the timer's classification again?
Oh, okay. Timer should be it's a behavior container. So it's just a basket that we can throw other behaviors into.
Is there other behavior containers that you could check to see if they work inside rules?
We can. Let's see. What else would be a behavior container? A rule would be a behavior container.
Is it because they're both behavior containers that it won't work?
Well, it seems like there's a reason why they're not working, but it doesn't, not a logical reason. I mean, it seems like if I'm asking the question, if a touch has happened, start this timer. That seems to be reasonable. I tried to click the run to completion. Maybe an interesting thing would be, say, for 10 seconds. And let's say run to completion. Let's see if it updates it then. Instead of saying every, maybe the everything is an aspect that does not work inside rules because it, maybe it syncs up with something.
Okay.
Seems like
It fired once.
I wonder if the timer only lasts as long as touch
The container lasts. Oh, that's actually a very good point. Let's set this to say every 1 second. So I'm going to touch and I'm going to hold. There we go. Yep. And actually, that's interesting.
So we need to make an if touch is released.
Yep. So I'm going to pretend like I did that on purpose. But I actually didn't, but it does make a lot of sense because of the way mobile application development works. If you're writing an iPhone app, and Android works the same way, whenever you touch on the screen, different events occur. So when you touch pressed, that's a different event than when you touch release. Two separate things. So for instance, when I code buttons, when I'm writing an iPhone app, I like to code the button so that it fires when I touch down on the button. So it's called touch down, touch up on iPhone are the events. I like it to be when you touch down, that way it has almost an instantaneous effect. The app feels very clicky. You know, you could tap and things move really quick. As opposed to having to tap and let go. You see the button to press then, and everything's all happy, but only if you release does the event actually fire. Well, what ends up happening is if you touch on a button and then your finger slides outside of the button and you let go there, the button doesn't receive the event because you're not inside of the button. Okay, so what we need to do here is if we touch it, then we're going to start this timer. Go ahead.
Could you just put that timer in the other rule and then just switch it to release because the other one doesn't really matter at that point?
We could certainly do that. So we can say touch released, then start this timer. We don't even. No, you wouldn't want to do that because I think it would be firing at all times.
Mm-hmm.
So let's just do this real quick. So you're saying couldn't we put it in the otherwise here?
Yeah, but you have to move it up. No, not the otherwise. You can keep it up in the rule with the do. So just move it up one level.
Okay.
Where the other ones are, and then just change it to is release, and then it still works.
Oh, okay, I gotcha. So what you're saying is kind of what I was just talking about.
Yeah.
Now, it doesn't happen when we first touch the button. It happens when we touch it and then let go, because that's the only time. So right now, the released event has not occurred because we haven't clicked it. As soon as we click it and then let go, this starts happening. Does that make sense? Because the released event has happened. Now, what's interesting is the release event seems to be persistent, but the touch event is not. The touch event is persistent as long as we hold. We saw that happen, right? But release, that only occurs when we release once. Just like when we touch, that should start the thing firing. But release seems to be persistent. Does it not?
Yeah.
Okay. At least comparatively. Okay. So that's getting the thing to go down. And it did seem like it updated. So when we click, it is falling out of the sky. Who knows if it's at the rate we want it to fall out of the sky, but it's doing what we want it to do. Okay. So let's go. Why are we doing it by 25? Well, I just made up that number. Maybe the better thing is, how much do we need to increase our, the downward force by in order to correctly simulate how long this ball is falling out of the sky?
Would we want to set it to gravity?
Okay, who owns gravity? I believe it's the scene.
No, it is the scene.
Okay, so the scene owns gravity. And we have gravity on Y, and it's a cumulative effect of 9.8. Correct? Why did we choose 9.8? Is that the force of gravity?
Realistic force.
Okay. Isn't 9.8 meters per second the terminal velocity as well? What is terminal velocity? It depends on mass? Okay. All right, so 9.8, then do we actually need to ask the scene for gravity? Or could we just use that value of 9.8? The issue here would be, let's assume that we are in the golf ball, and actually not the golf ball, it's the start button, right? We're in the start button, and we want to use gravity. So rather than hard coding in the 9.8, we want to actually ask, in case we ever update gravity later. Okay, if we update gravity later, we don't want our golf ball, if we're simulating on the moon that has different gravity, we don't want our golf ball to keep going at 9.8. But what if we wanted to link this to the current force on gravity on Y? How could we do it inside here? So we're going to update force. We know that for our Earth gravity, we're going to just see plus 9.8, right? So this would be correct for right now. So if I run this, this should be falling out of the sky at the rate of real life. Okay? Now, the only thing that's not happening is our speed's not slowing down. That's why these would be very long drives, especially after it hits the ground and just keeps 120 miles an hour just rolling out. How do I increase it by whatever gravity is? We need to be able to ask the scene for the current gravity value, right? How do we get to the scene? If I come in here and I say plus, I have access to the game. I have access to the device, whatever device you're playing this on. I have access to the start button, but I don't have access to the scene. So let me show you this real quick in our last couple of minutes. So what I'm going to do is I'm going to leave this value as it is right now. Okay? And I'm going to come in and I'm going to edit the actual instance of the start button in our scene. Okay? Because we imagine there's only going to be one of these start buttons, correct? So this isn't dangerous. But it is something we need to think about. The second we unlock this and we start making changes, those changes are to this particular instance of this actor, not to the prototype of the actor. That makes sense? But if we're operating on this exact instance of this guy, now what I can do is I can add to this our current scene's gravitational force on Y. Does that make sense? So because I am editing the instance of this actor that lives within the scene, he has access to the scene. But the prototype does not know about the scene that he will eventually live in.
Where's the timer at in that one? Yeah.
Did I not put the timer?
Your timer's not in there.
Actually, interesting. That is interesting.
Because then you'd have to put it in the timer one, not the launch angle, right?
Yeah, that's actually interesting why the timer didn't come in. We can go put it in. I just wonder why it's not why they didn't bring that part of the prototype over. So we'll go ahead and throw the timer back in. Maybe it's something with threads that timers are dangerous, so it makes you confirm that you still want the timer. I know it seems to be kind of crappy, but
Well, if it's in the prototype, do we have to worry about it not being in the instance?
it wasn't in the instance. I mean, we're looking at the instance right here. As soon as we unhook that lock, they're no longer linked.
All right.
That's why we have this button up here to revert to prototype.
Okay.
Okay, so I can't necessarily give you a great answer as to why when I unlocked it, it didn't bring that timer over. It must be that timers are considered dangerous because it creates another thread. So think of it like a memory leak thing. Well, every thread of execution that your game is running hurts performance of your game. So that's the best guess I can make right now. But in any case, we'll say every 1 second, what do we want to do? We want to change an attribute.
It's still in your other variable.
It's up there.
Huh?
Your game launch angle, that's where you added it, I think.
Oh, so that's just still there. It's just not in.
Well, you didn't want that there.
You still added the number.
You added it to it on accident.
There.
See?
Well,
Right there.
intentionally, but to the wrong.
Yeah.
Oh, I understand. Wait, hold on. This is correct. I just want it inside of my timer.
Yeah.
Yeah.
But
So
you don't want it where?
No.
That's your live velocity.
all right. What am I missing here?
You,
That should be just gain launch angle. Because then you're gonna have a new. You've got your current ball speed.
Oh. I'm with you. I'm with you. So I need to change a different attribute in here.
Yes.
The attribute I'm changing in here is my game's downward force to be whatever my game's current downward force is. Plus my current scene's gravity on Y. Okay, so the punchline here is, do we understand how we can access gravity? We have to be within the scene, so that's where we have to modify an individual instance. So as of right now, we should be able to hit this, and gravity should update.
Yep.
Okay, that makes sense? He's updating by gravity, and we saw it's a cumulative force. So we'll come back next time. We have to think about how do we translate this into yards, and how do we artificially slow down miles per hour. Initially, we'll probably just say we're slowing down by 25 miles per hour per... What's this? No homework. All right. I'll see everybody on Wednesday.
so our like 120 or whatever the distance is that we set, is that in yards?
That's in miles per hour. Yeah, 120 miles per hour. That's ball speed. Distance, we want to get in yards. Yeah, so we're going to have all the stuff add up in the end.
Yeehaw.
Let me stop the recording before I forget.